Hello and welcome to the third chapter of our course on the fundamentals of card payment. This chapter is called Global Processing, and we are going to discuss what it means to transact on a global scale. In this first lesson, we're going to talk about payment messages. We will only scratch the surface here, but we have a full course on ISO 8583 and transaction processing if you're interested to learn more. Let's start with the general concept. Services of the financial industry include the exchange of electronic messages relating to financial transactions. ISO 8583 is designed as an interface specification, enabling messages to be exchanged between systems, adopting a variety of application specifications. This is what you can see on the bottom diagram. The merchant terminal communicating with the acquirer host, the acquirer communicating with the payment network, and the payment network communicating with the issuer. And those are just a few examples. There are also other types of payment messages using field separators, XML, and so on. More on the general concept, maybe phrased differently. ISO 8583 is an international standard for financial transaction card-originated interchange messaging. It is the International Organization for Standardization standard for systems that exchange electronic transactions initiated by cardholders using payment cards. The vast majority of transactions made when a customer uses a card to make a payment in a store use ISO 8583 at some point in the communication chain, as do transactions made at ATMs. Although ISO 8583 defines a common standard, it is not typically used directly by systems or networks. It defines many standard fields, data elements, which remain the same in all systems or networks, and leaves a few additional fields for passing network-specific details. These fields are used by each network to adapt the standard for its own use with custom fields and custom usages. Let's now look at the concept of message. ISO 8583 defines a message as a set of data elements used to exchange information between institutions or their agents. An important point is that no communications, so that header, trailer, protocol, or character code, or security implications, are assumed or identified. If you look at the image of the two servers exchanging information, ISO 8583 defines how they would interpret data at a high level. But there are lots of low-level details that need to be worked out between those two servers in order for them to exchange information. And this is outside the scope of ISO 8583 and left for the top layer protocol or application-specific protocol to make decisions on. Messages are defined by their class. The main message classes are authorizations, financial messages, reversal messages, and network management messages. And messages are also defined by their function. The main functions are requests, responses to requests, advice, and responses to advice. Let's start with authorization messages. An authorization is an approval or guarantee of funds given by the card issuer to the acquirer. Authorization messages are not intended to permit the application of the approved transaction amount to the cardholder's account for billing or posting. A request is a message where the sender informs the receiver that a transaction is in progress and a response is required to complete the activity. Let's look at authorization advice. It has the same class, so it's also an approval or guarantee of funds given by the card issuer to the acquirer. But an advice is a message where the sender notifies the receiver of an activity that has been taken, requiring no approval but requiring a response. For example, a payment network like Visa might notify a card issuer that it authorized a transaction on their behalf because the link to the bank was down, and now the issuer needs to deal with the authorization. Let's now look at financial transactions. A financial transaction permits the application of the approved transaction amount to the cardholder's account for billing or posting. And messages can also take the form of a request or an advice. Let's move to reversal messages. A reversal is a transaction from the acquirer to the card issuer, informing the card issuer that the previously initiated transaction cannot be processed as instructed. For example, if it is undeliverable, unprocessed, or cancelled by the receiver. This diagram shows the overall picture of the transaction flow. The transaction starts. It can take the form of an authorization. And if the authorization is declined, or if the protocol uses a different mechanism like clearing files to complete transactions, this might be the end of the transaction as seen by ISO 8583. The authorization might be followed by a financial message, typically a financial advice, to complete the transaction. The transaction can take the form of a single pair of financial request and response messages. Both authorization and financial transactions might be reversed, partially or fully, which leads to the end of the transaction from the point of view of ISO 8583. And financial transactions may be followed by a chargeback message. And this is the whole picture. Again, this is defined by ISO 8583. Individual protocols would tend to redefine this, or support only a subset of the whole picture based on the business cases that they support. On top of transaction-oriented messages, systems also support network management messages. Network management messages shall be used to control the system security and operating condition of the interchange network, and may be initiated by any interchanging party. The types of network management messages are system condition messages, system security messages, system accounting messages, and system audit control messages. The overall picture looks something like this, times a million. We are working on a global scale, with a number of international payment networks, and a much larger number of domestic networks. Every country has at least tens of acquirers, acquiring from thousands of devices. And every country has hundreds of card issuers, and all those players are interconnected. Going from the terminal to the issuer is not a major issue. A request message is simply forwarded by the intervening systems to get to the card issuer. But considering that each player can process hundreds of transactions per minute, when they receive a response message, they need to tie it back to the original message to find out where it came from, and therefore where to send it back. What typically happens is that when a request message is sent or forwarded, a copy of the message is kept in the database. And when a response arrives, the system does the database search to retrieve the original message. If you've done a bit of work with databases, you might know that a database table usually contains a primary key, which uniquely identifies an entry in that table. And when a response message is received, the system needs to be able to regenerate this primary key to retrieve the original message. What constitutes a primary key depends on the kind of payment switch or payment host that is used. In general, you want to use something that is unique to a transaction, which is typically a combination of several data elements. It might be a combination of the PAN, amount, terminal ID, and date and time of the transmission. In any case, those data elements must have the same value in the response message as they had in the original message, so that systems can complete whatever process they use to retrieve the original message, which allows the response message to make its way back to where it originated. At the heart of this whole system are card numbers that are globally unique. The leading 6 digits of the PAN constitute the Issuer Identification Number, or IIN. This is commonly referred to as the Bank Identification Number, or BIN. For example, PAN 4761 7390 0100 8402 has been 476173. The bin gives an indication of the brand that the card is issued on, and this gives you a hint as to where in the system the transaction will go to. This can be useful when you need to follow a transaction through the various processes inside a payment switch. Every card brand has a bin that they use specifically for testing. That means that it does not belong to an issuer, but is reserved by the brand for testing purposes. Transactions with a PAN under such a bin are always authorized by a simulator. This is an example where an acquirer is conducting some testing, and the payment network has been replaced by a simulator. This kind of scenario can happen anywhere on the payment chain. In general, the test bins are registered on the simulators so that they can authorize and approve test transactions. This table shows how to tell what card brand a PAN belongs to. A PAN starting with 4 is a Visa card, and the test bin for Visa is 476173. A PAN starting with 51 to 55 is a MasterCard card, and the test bin for MasterCard is 541333. A PAN starting with 56 to 58 or with 6 is a Maestro card, and the test bin for Maestro is 679999. A PAN starting with 34 or 37 is an American Express card, and the test bin for American Express is 374245. A PAN starting with 36 is a Diners Club card, and the test bin for Diners Club is 360705. A PAN starting with 64 or 65 is a Discover card, and the test bin for Discover is 651000. A PAN starting with 3528 to 3589 is a JCB card, and the test bin for JCB is 356999. We are only showing the main international payment networks. You could build a similar table for domestic networks. This concludes the first lesson in this chapter. Thank you for watching it. And if you want to get an in-depth understanding of payment messages, you can check out our expert course, ISO 8583 and Transaction Processing from Terminal to Issuer. It has already helped many people in their daily work. There are no prerequisites, we teach everything from the ground up, and there's a free trial, so don't hesitate.